Good day, everyone. Today we are going to learn all about the electromagnetic spectrum. So sit back, relax, and enjoy watching. First, what is an EMS or electromagnetic spectrum? According to Britannica.com, electromagnetic spectrum is an entire distribution of electromagnetic radiation according to frequency or wavelength. This electromagnetic spectrum is further divided into many subranges known as portions. But before we go tackling about this electromagnetic spectrum portions, let's all be familiarized with frequency and wavelength. So what is frequency? Frequency is the number of occurrences of repeating event per unit of time, which can be written frequency is equal to 1 over time. Wavelength, on the other hand, is the distance between identical points in the adjacent cycles of a waveform signal, which is crest to crest or throws to throws. So what's the relationship between frequencies and wavelengths? Easy. It can be written as V is equal to lambda F, where V is the wave velocity or how fast the wave propagates in the medium. Lambda is the wavelength or distance over which a wave shape repeats, and F as the wave frequency. However, for light and other electromagnetic radiation in a vacuum, the wave velocity is the speed of light, or can be written as C is equal to lambda F.
Electromagnetic spectrum. The electromagnetic spectrum is a range based on frequency, wavelength, and energy. In terms of frequency, it's a range from the lowest frequency to the highest frequency. In wavelength, it starts from the largest wavelength to the shortest wavelength. In terms of energy, it starts with the least energy to the most energy. The first wave is the radio wave, with the highest wavelength but lowest in frequency and energy. Next is the microwave, followed by infrared, visible light, ultraviolet, and X-ray. Lastly, the lowest in wavelength but highest in frequency and energy is the gamma wave, and that's how the electromagnetic spectrum is arranged.
First, the radio waves. This is used for television, radio broadcasts, military communication, mobile phones, and other numerous communication applications. Microwave. It is also used in communication, radio astronomy, remote sensing, radar, and cooking. Infrared. This can be used to study human and animal body heat patterns, but more often they are used as night vision cameras. Visible light. Aside from sight, there are other important uses for visible light. We concentrate it to make lasers to use in everything from surgery to CD players to laser pointers. Visible light waves also make our TV, computer, and cell phone screens work. Ultraviolet. Ultraviolet radiation is widely used in industrial processes, in medical and dental practices for a variety of purposes, such as killing bacteria, creating fluorescent effects, curing inks and resin, phototherapy, and sun tanning. X-rays. They are mainly used in medical to look at the bones and joints, although they are sometimes used to detect problems affecting soft tissues such as internal organs. Gamma rays. They are used in medicine for radiotherapy, industry for sterilization and disinfection, and nuclear industry. And that's all for this video presentation. Thank you for watching.